Hi, I'm Andrew Kemendo, currently the Chief Technology Officer at Kessel, which is the United States Air Force's premier software factory, you could call it. We're really more of an acquisitions and operations organization, and we're going to talk through some of the details around some of those distinctions. But really, this brief came about because I've talked in the past with folks about what is a TRL-like structure for artificial intelligence. So when do you know you're ready, or how can we get to a readiness level for things like advanced automation? And that's something I'll continue to come back to throughout this brief, because I don't love the term AI, especially in this context, but we'll use it to inform kind of how we think about this problem. Quick background on me. Started my career in the United States Air Force as a intelligence officer. I worked out at PACAF for a while, working at the 36th Wing, which is Anderson Air Force Base in Guam. I was a senior intelligence officer out there. I did almost a year of a deployment to Iraq and then came back and worked for the Contingency Response Group, doing some interesting things worldwide. From there, I moved on to the Defense Intelligence Agency, where I did counterintelligence and HUMINT for East Asia primarily, but also around the Washington, D.C. area, doing some interesting things. I separated from the Air Force at the end of 2014 to start my own company, specifically around computer vision and augmented reality, and it was called PAIR. Actually, we started working with architects and engineers originally, and then eventually pivoted into home furnishings. So happy to go through those details offline if anybody wants to talk through that. But really had a crash course in how do you do, no kidding, artificial intelligence applications, not only pre the kind of CNN, DNN explosion, but also after we found that there's real world applications to deep neural networks, image processing primarily, so around computer vision. And then at the end of 2018, or into 2019, I joined Kessel as our first chief data officer with a team of one. I grew that into a data operations portfolio, and we had about 300 data engineers and data scientists. A lot of the learnings that I'm going to go through here kind of come from that experience. And now, within the last about 2 months, I was asked to become the chief technology officer to oversee all of our work. So really quick background there. Always happy to take questions or thoughts on, my transitions or kind of in and out of government and how that's all worked and how each of them inform the other. So one of the things I always like to ask is, what do successful everyday uses of artificial intelligence look like? And I put that caveat on there, the little asterisk, just to say, we're talking specifically here about unclassified non-DoD systems. So things that you would typically see in your day-to-day life that you're going to interact with, and you may not necessarily know that they're using deep neural networks or they're using large data sets or things like that. But most of the people should be aware, at least for this crowd, of how they work. But a couple of examples I always like to look at are across some of the platforms and applications we use today. So Google Maps, obviously, that uses a lot of deep reinforcement learning. They use a lot of just basic machine learning research and applications, obviously. And that wasn't new, right? That was, or that is new rather. It's not brand new that they're doing that. They've been doing it a while, but it hasn't been the entire time that they've been in business. Same thing with Gmail. So, for example, I show here the autocomplete feature, which is relatively new, only in the last year and a half. Same thing with Spotify. So Discover Weekly, Release Radar, the other For You type playlists. These are all, no kidding, software applications of deep neural networks and deep learning. On the Apple side, it's actually interesting because they've been integrating more and more hardware level deep networks. And what you see from this image here is how segmentation of backgrounds works on device and on chip. And so integrating at the edge is what a lot of people like to call it, right? Integrating some of those deep learning capabilities at the edge. These are where we start to see this kind of boundary. One of the really important things I think to recognize here, though, is all of these were giant, large platforms with a lot of time understanding their product and getting good user feedback and really building that out before they started implementing deep networks or AI or ML generally. Some earlier than others, but as a general use case, these systems, these projects, these products were around for a while, and they had a solid user base and they had a solid product that wasn't going anywhere for quite some time before they actually rolled some of these features out. And so one of the things I like to talk about is what is the actual recipe for successful artificial intelligence. So successful artificial intelligence. And if we really look at it and we break down some of those previous examples that I talked through already, you can find a consistent pattern for the successful use of artificial intelligence in a product. That really starts with stable infrastructure. So when we talk about infrastructure, we need to go all the way down to the user level and everywhere in between. So infrastructure, in this case, I'm talking about specifically, you have networks, you have great networks. You have compute and store all available and robust and reliable. You have a application platform like iOS or Android that you can consistently build on. They have frameworks and they have libraries that are regularly updated. And then they have a user base that is actually using them, right? So when we're talking infrastructure, it's really important to say, do all of the hard components exist already as the base layer, right? This kind of tabletop I'm talking about here. Do those exist already? Because if they don't, you don't really have anything to start from. So stable infrastructure is an absolutely core piece of everything that we're talking about here when we talk about how do you get AI into production and whether or not you're really ready for it. The second major component, at least the way I view it, is that once you have the infrastructure and you know that you've got something there, you have a team of capable people to be able to develop on top of that infrastructure. So that means everything from product management, software engineering, data scientists, site reliability engineers. The list goes on in terms of, do you have the actual competent team to be able to do what you need to do to build a basic product and then iterate on that product until you get to the ability to do automation and optimization. So infrastructure, absolutely key. A competent team, and especially when we talk about AI and more advanced methods, you start to build up the layers of product competency in your team and then optimization competency in your team and your organization as a whole. As you get more and more complex, some of these things will get pieced out and shredded out to platforms that you may need to build yourself to be able to service different parts of your organization. But fundamentally for a product, you actually have to have a competent team structure all the way through your machine learning researchers who are going to be pushing the boundaries on what is possible. So once you have that team and you know what you're supposed to be building, or you think you know what you're supposed to be building, having a stable product is really, really critical. So if you have a product that is in MVP, or you don't quite have product market fit yet, or you're early on actually rolling it out, you're just now getting user feedback on a very basic product, it's oftentimes not ready for machine learning. There are products certainly now that are based on ML workflows that slightly go back and forth on the capability here, but those are really new within the last, let's call it 5 years. Those are fairly new things, and they don't really have great design patterns around them yet. So if you look at Algorithmia, for example, that is a machine learning platform or machine learning algorithmic trading platform in effect. And when I say trading, it's really just, can we share models with each other? That's a fairly new product, and that's a fairly new model that's basically built around ML development, right? So those are types of things where absolutely they start with ML, right? Or in some cases, facial recognition detectors, those things start with ML. But generally speaking, if you look at the scope of what is possible and kind of back to those early examples, you do need a stable product before you are able to go and iterate on it. And there's enough problems out there that don't have great products and don't have stability around products that are ripe for change already. So that doesn't necessarily mean that you can't start with an ML product. It just means that you're probably better off starting with a product that you think is already solid, that has a great user base, that you can start doing the next step. And that next step is collecting data. That really starts with just basic metrics. So how many users do you have? How long are they using a feature? How long are they in the application in total? Do they only need to use it once a month, or do they use it every hour of every day? For the DoD specifically, oftentimes we're talking about applications that only have a handful of users, but they're using it a lot. In many other cases for our business systems, obviously it's a lot of users using it consistently. Things like TMT or some of our time tracking, time management applications. Those are obviously in a different category, and they allow for a lot of large data collection very easily. For some of our operations software, it's a little bit harder because we have very small user bases, but they really need to use those and they really need to be critical. So when we're talking through this like kind of layer cake here, those stable products, right, with a real user base, sometimes data collection is not going to come at the same pace as you would expect for other applications, like in the private sector. But it's really important that you actually have this as a capability. So beyond just the basic metrics capability of what are we doing, can we actually make improvements and optimizations around those workflows? You actually need to start collecting data from the operational side of that. So no kidding, what kind of invoices, for example, in an ERP system are being put in? How do we metadata tag each of the elements that we have? On the classification side, can we actually do per entry classifications for each particular type of data so that we can push it to the right place in order to do the appropriate machine learning research in those security boundaries? So these are really important and critical pieces to getting us along the way to AI readiness. Do you have the ability, and have you started doing the data collection already? I think once you have infrastructure, your team, your stable product, and you have some data collection started, you're now starting to be able to do experiments. And that means taking the data that you do have and doing A/B testing, basic things. You can also branch or fork products or projects to be able to say, well, what would it look like if we were able to automate this one function or feature? And I think it's a really important piece to identify that when we're talking those first kind of examples, each of those uses of ML or RL in some cases were features as part of the larger product. They weren't the product themselves necessarily. And so that's where you start to look is, what are the candidates for feature automation that we can start looking at that are going to give us what we need in order to start moving forward? And I think at this point, you could probably consider yourself ready for AI. If you're able to do the experiments, then you're basically already all the way to getting to some production level capability. But you're not quite there yet, because the production AI system actually means that you're building it into your continuous integration and your continuous development. And that's where we consider things like ML ops important. Making sure that our machine learning models don't drift, for example, that we're continuously updating them for new data types that come in, especially for critical things like targeting or computer vision type problems when we're finding newer and newer things that we need to classify or newer objects or features that we need to classify. Having those production AI systems make sure that we're getting the feedback that we need and building in, again, those data collection pieces so that we're getting the right product out and consistent. Without the stable infrastructure, you won't be able to run it in the right place or at the speed that you need to run it. Without your team, you're not going to be able to actually competently deliver and build all those through the product lifecycle. Again, if the product goes away, if people don't want to use the basic product, then your machine learning is not going to be very successful, because you're just, as a feature, it's not going to be capable. And then again, back to those experiments and the data collection. So really the whole cake always depends on itself. And it's important, kind of the way I built that shows that if you take out some of those lower layers, you're not going to be able to have that higher order piece. a big takeaway here I think you should come away with is you will not succeed with AI if you have bad products or your organizations are bad. And we've seen this time and time again where we try to apply advanced techniques or some new modeling technique or an optimization. The challenge, though, is that if you do not have solid products or you do not have the right people or your infrastructure isn't quite there, you're going to basically spend tons of resources on the wrong problem. And I think it's just really key to continue to go back to say, as part of basic product management, are we on track with how do we deliver value with a great product and make sure that we have the right organization to develop and build and get that into production for people. If your goal, though, is to accelerate how quickly you waste money, right? Burn bridges with all those folks who have taken time to work for the DoD when they could be working other places. If you want to really make bad decisions faster, breed cynicism with your workforce, and just generally build the wrong thing, then absolutely go ahead and apply artificial intelligence before you're ready. I can tell you again from experience, and I've had to learn this lesson the hard way many times, is that optimization prematurely will not lead you to the outcome that you want. You cannot fix a bad organization, you cannot fix a bad product by throwing optimization at it. You end up just optimizing again for the wrong thing. So by all means, if you want to rush ahead and try to do stuff, you can. And that's not to say that it's impossible to be successful if you're not quite ready. It just means you're going to have a lot of hurdles that you wouldn't necessarily have otherwise. And it might take a little bit more going back and fixing some of the basic things first before you're actually able to reap the benefits of those. So try to make it easy here and get people kind of up to speed. I've just put together this kind of 5 basic puzzle pieces for the AI readiness. And they really just go back to the kind of layer cake that I've already put together. But hopefully this next section will give you what you need in order to ask the right questions of yourself and your organization for whether or not you're ready to get started. So let's start with the first one. Do you have the infrastructure? And this is a piece that is often overlooked because it's not one size fits all, and for every single different product, it might be slightly different. So if we just look through what we need, having a developer environment is key, or is one of the first keys. To be able to actually do, no kidding, AI development or product development or otherwise, you need to be able to actually own and understand the environments that your products are going to be developed, and with the idea that the end user should have a fairly similar or almost exactly similar environment as those of the developer in effect. Or you should be able to have the ability to test those. So to that environment piece, do you actually have the compute that you need in order to do it? I caveat that with a lot of people want to go out and just buy GPUs because that's what we use to train and test and really in many cases run inference on our models. It's an important piece of the puzzle, especially when you want to get to speed, but it doesn't necessarily have to be a requirement for you to get started. And it's an important piece to understand is that it will be likely key to your being able to do things, but pace out when you actually need it so that you're not overrunning your costs. So accessible compute, there's a big push for the cloud, of course, right now inside the DoD and really everywhere. And so that can solve some of those problems. And same thing with storage, right? Making sure that you have sufficient storage as you're doing your metric generation and your data capture. Those are really, really key pieces. So when we talk about cloud can solve some of these, it's true. However, in many cases, cloud is not there on the network that you need, especially for the DoD and the intelligence community. It's not necessarily there or easy to get to on the networks that you need. It's really a foot stomp of mine that it's very, very, very difficult to build machine learning capabilities on a classification system that's lower than the classification of your data, because then you even have to do it by, in effect, synthesizing the data you need to reflect it, or you have to do a lot of cleaning and work to downgrade that data. And then, are those scalable and are they reliable from the infrastructure perspective? Generally speaking, within the DoD, that becomes a little bit harder. Some places are absolutely great with that. As a general rule, though, I think we can all agree that we're not quite where we would want to be in terms of scalable and reliable for all computing environments within the DoD and IC. So how we get after this with Kessel Run is really we kind of run our own network and we run our own system. We have the regional air operations centers, in addition to our cloud instances where we actually build out the Kessel Run all-domain common platform. So everything from compute and store to the network pathways. In many cases, we don't own all of them either, but we do have priority on others. It still is a challenge, even for us, where we do own and can upgrade and maintain our own hardware stacks. Our cloud instances, we can manage them, we budget for them, we acquire them. All the things that you need to do to have ownership over that infrastructure, make it stable, make it reliable, make it repeatable. We're doing our best to get after that, and we're doing a pretty good job considering the constraints. We understand, though, and we appreciate that not everybody has the ability and the access to do that. And in many cases, we let other organizations run on our hardware and our software. So we are doing our best to get after that. But it's really important to understand that even with the capabilities that we have to run our own, it's not necessarily always a slam dunk. So really important that you get a firm understanding of the infrastructure that you're going to be running and you're working with before you really get started, and that you have some competencies there to be able to do what you need to do. The second major piece that I really put a lot of emphasis on, because I think it's one of the hardest ones to have, or we need to do the most development on this in the DoD, in my opinion, is having the right people. For any problem like this, where we're developing new solutions or we're coming up with new capabilities, you really do need very, very competent people. There is a place for entry-level folks. There is a place for training and education here, but we're kind of we need to ramp up the scale of which that we have those right types of people across the Department of Defense to be able to move around and understand the problem sets, have the clearances and everything you need in order to get up and running. What we've seen a lot is that there's a lot of contracts out there with groups that don't have secure engineers. They've never worked with the DoD. They don't quite understand the DoD processes and how we do things or the culture. And those things often kind of go sideways. So we've done our best to really try to bring these people in as government civilians as much as possible. And then where we do have contracts, we really make sure that they're focused on developing people. So on down the list, software engineers all the way through reinforcement learning engineers. These are the people that you need to start identifying for your particular problem set. And frankly, having great leaders who understand the complexities and the intricacies of how do you build software, number one, how do you run infrastructure and the software around that, number two, and then three, build more optimizations and ML workflows around that. It's really key to have those leaders. A couple things that we've done and I really focused on was building out our data science enterprise contracts. And we did this a little bit differently than most contracts we build. Still time and materials, looking for people, but instead of it just being an objective for we're going to try to get after a particular type, right, of product, we really want a type of person who then can be directed and work together with our product designers and our product engineers to develop the right thing. And so we did something interesting, which is effectively a take-home challenge to say, okay, you're going to build us something that looks like what we would want. We're not going to tell you how to do it, and we're also not going to tell you what the end result is, aside from a couple of core, really important outputs, right, which we put in the in the outputs of the challenge, and then we give that over to our contract folks, and they work with our contracting officers to figure out, okay, who can actually take the challenge, and then we'll evaluate them on this. And part of that is a huge evaluation process, which takes a lot of time, but it's really important because this allows us now to scale, and we have some absolutely fantastic companies who are working hand in glove to build products, right? Not to deliver a product, which we would then have to go through authorities and all the rest of that. But we build the products inside Kessel Run with developers. And so you see there on the KPPs, this is kind of what we generally get after is for the key personnel that we're looking for, they've got a range of experience all the way from very relatively easy things like just knowing Python or knowing how to do database management or build APIs, to some mid-level, event streaming with Kafka. How do we do basic analytics with Kibana and the rest of these? Ops research, machine learning, some touch points, and then really have some really deep experts in Markov decision processes, things like stochastic finite state machines. So trying to get after the harder problems that don't necessarily just lend themselves to machine learning or deep learning, but also optimization generally. So we really view this as a personnel, or collaborative personnel effort between contract folks that we wouldn't necessarily be able to get as full-time government employees, because of pay or many of the timing, things like this, flexibility, and pair them with the people that we are hiring as full-time folks who will come on as, no kidding, PhD researchers into an ops position as a government civilian. So, getting after the people is probably one of the harder things, and takes a lot of time and a lot of thought. So, really need to go into depth on how you manage that. Another piece that we do is we really do a lot of evaluation of our people, to make sure that they're up to speed and where their level is, so that we can make sure that within the organization for the people that we do hire full-time as either government civilians, or we have quite a lot of military, no kidding, uniformed military folks, how do we actually rank them? How do we evaluate them so that we can know who needs to come up into leadership position, who's better at management, who's really great as an individual contributor, and all the rest. This also gives us our baseline for how we do civilian hiring and military hiring, for the next step. So we can evaluate somebody as they come in and say, okay, well, they're probably at a level 300 right now, and we don't really have a lot of openings for 300s, but we do have a level 200 opening that would then be able to kind of walk into that, or vice versa. We think that they can fill a level 4 hiring position, and we would just need to upskill them on a couple things. So it's really a great way for us to get at a really coherent and objective process, as objective as possible process for evaluating our people. So just as important as bringing the right people on is making sure that we're evaluating them correctly, and quite frankly, getting bad people out quickly, and making sure that we retain our really, really great people. So going into the details here in a way that's not traditional with, for example, acquisition demo or the GS rating systems, we try to take a spin on that really gives us some quantifiable capability for evaluating our people. It's really important. We talked about product a lot, I think, in the beginning, but a big piece of product stability is, no kidding, being able to do release stability, having a really well-defined user base, having a consistent feedback loop with the users, right? And making sure that you're developing the right thing. Right now in the DoD, we are doing some interesting things in the sense that we've got a lot of really old problems, or a lot of really old projects and products, tons of user base, right? No feedback. On the flip side, we have brand new products with a lot of feedback coming out of many different software factories and efforts and things like that. We try to have to find the way to work between these, where old programs, I say old, but programs that are legacy programs or they've been around for a decade or more, how do we build those feedback mechanisms in? How do we build metrics into our systems? Do we give users an option? How do we roll these things out? And kind of that product market fit. Product market fit in the commercial sector really means, are you solving almost perfectly a problem for your desired user base, such that they're going to come back no matter what to do that major capability, that major workflow that you're giving them. That doesn't mean that's your whole product, but that you have something that keeps them coming back, that you absolutely are providing value for on a regular, everyday basis. A couple examples from Kessel Run. Jigsaw, it's almost 3 years old at this point. We've got thousands of users around the world, and we've had at least 40 releases over just the last, I'd say in the last year, right? And getting after more and more stability, and our releases are really bug fixes and small things like that. So we do have user bases already, and we're building out workflows for our customers specifically, and trying to use some of these as branching points for other organizations. So not necessarily just an air operations center can use these types of things, but the learnings from our product development cycle will be able to continue to go back into that. And as we expand, get more feedback from edge cases. Another example is Odin. So Odin is part of the F-35 maintenance scheduling system, just over a year old, 150 users, really starting to get into a release pipeline and really making an impact. So not quite perfectly to the level of scale and interoperability and integration yet, but the idea is that we have enough feedback at this point and enough usage to know, is this a solid product? Is this a usable product? Do we have stickiness? All the things that we talked about before in terms of, is this a capability that we want to continue using? So these are requirements before we even started getting into the optimization piece. And just a point on that is that those people that we're talking about, the software engineers, they're critical to this, right? So we can't do ML if we don't have great products, and we can't have great products if we don't have great software engineers and product management. Moving on to the data piece, right? So once we've got a great team building a great product on stable infrastructure, now we can actually start, and actually you should start doing this from the beginning, but making sure that you have instrumentation for that application to be able to do things like logging, use usable metrics from usage, metadata, kind of all the things that we talked about, or I talked about in the very beginning. Do you have remote procedure call systems? Are your APIs well instrumented? Are they easy to understand? Can other people use them well, right? Are they inter-organizational APIs, or how are you building those workflows? A couple of things that are really interesting also is query and ETL capabilities. So that's extract, transform, load for folks who aren't familiar with the term. But there's a trend to try to data warehouse at a very large level to say, okay, well, we're just going to dump all of our data into one place. It's a simple way to do it conceptually. There's a lot of challenges with that, especially when it comes to doing things like query, as well as for doing data distribution and having secure data warehousing and some of these things. It's not to say it's always inappropriate, but you should really think about, are you doing your data the right way? And putting things into a data lake in some cases has a great benefit, but oftentimes can get a little bit unwieldy. And then, at the more advanced level, you can start thinking about eventing systems using things like Kafka. That's why I want to show kind of what we do. Again, I talked about the Jigsaw application here. As we actually run the software and have people use it, we are pulling out each of these metrics at different levels. So not only just the user analytics, but also kind of underneath the hood, what's going on with the application itself. Are we using too much CPU compute? Do we need to fail over to new servers? Things like this, just to give us the data that we need to be able to do the job correctly and provide a good product and really get after, in effect, what we want as really sticky products and really capable product for our end user. And those end users will then stay on, and we can continue to gather more and more data and optimize further exactly what we're trying to do towards a more automated, towards a more optimized system. And as you can see, I'm just letting this video run, but over time you get more and more metrics, even just from a cold start, as long as you have a handful of users then that you can actually start pulling these from. So those kind of feed into this event stream, and I always look at this event stream as one of thousands of event streams that we have, and we're trying to get them to a combined event stream that we can then start doing some real interesting processing on. That's what we call Rebel Alliance. So these are part of the ways that we're getting after some of these problems as Kessel run. The last, kind of next to last piece is, are we doing the experimenting, right? And before we get everything into production is, are you doing those experiments? So actually understanding candidates inside your applications for automation. What are what's the coupling between the capabilities that we have today in machine learning and operations research or other statistics packages, optimizers, and can we couple those with the problems that we have and the features that we have inside the applications today? You really do need a test and evaluation infrastructure. So having a place where you can play with the real data with some of these tools that's not your production system, really critical, right? You don't want to be trying to test new things in your production systems. Again, being scientific about it. Can you repeat? Can you reproduce results? on a regular basis. Those are some of the criteria that we really think about when it comes to proving out that our automation systems actually are optimal or doing better than the systems that we're automating, right? So being able to have confidence and repeatability in what we do is a part of the selling point for that optimization piece. And also gives confidence to our war planners, our stakeholders generally, that we're not just doing random things out there, that they are actually functional and capable automation systems that we can rely on for critical, capable workloads. A/B testing and user acceptance, these are all part of the do you do it correctly? Are you just kind of basic software piece? But also really important to roll your machine learning capabilities out in the same way as new features and new functions. Because again, it's really just a new feature, or it's a change of a feature that we're talking about, and making sure that your users are okay with it. In many cases, you might be actually obviating somebody's work. And so having a user acceptance, it can be tense at times to say, well, I used to do this, and that was like half of my day. And so now if I don't do that for half of my day, what am I supposed to do? And the hope is that commanders and other organizations will say, well, we can give you higher priority work, or we can give you better value work to be doing than something we're automating. So it's really a back and flow work between the user and the product and machine learning developer. And then model management and the rest of this is all part of it, is part of just making sure your experimentation frameworks make sense. So when we talk about what's Kessel Run doing for experiments, Pythagoras has been around a while, but really it's trying to get after how do we take that jigsaw problem of allocating tankers and their resources and doing it in an automated fashion or doing it in an optimized fashion such that tanker planners can do higher value work, or we can actually get to faster planning than a human would be able to otherwise. And we're not quite in production yet, and that's good, because we're really still working through our user base and making sure that they're good with it. So going through user acceptance testing, making sure our infrastructure is there. A perfect example here is that for this particular application, it's not using ML capabilities, it's actually using linear optimizers, and those linear optimizers are expensive in many cases to run on a regular basis just for licensing. And so how do you reuse some of that licensing by doing things as a service for ourselves? So we buy different ways to kind of split up our CPU compute and the rest of these, right? So getting at that production level stuff requires getting the feedback from those experiments in production, or not in production, but those experiments with the user rather. Minerva is another great example. So we talked about Odin already. For scheduling maintenance, how do you optimize that? And the feedback that we're getting already is we can basically condense hours of manual scheduling and optimization down to seconds. Again, we're working through user acceptance testing here, but we're making good progress. Again, we're talking linear optimizers here. In many cases, we don't have the data, or it's going to take years to get the type of data that we need in order to build a deep reinforcement learning model, or a deep NLP model, or any of these like larger models. Now, there's some interesting things happening, of course, with single shot learning, few shot learning, and the rest. But again, you kind of have to do the basics first to figure out how do we roll these things out as we get better and better at basically building our processes up. So that's how we experiment, and a couple just examples of how we're doing some of that experimentation. Once you kind of have all of these 5 pieces, then I would argue you're probably close to AI ready in your organization. I think we could ask the question, is Kessel Run AI ready? And I don't know if we're just barely ready. I think we are, in the sense that we've started to do real experiments with real users in a place where people can get acceptance testing and understand what the implications of those are. But we don't have perfect infrastructure, right? We're still working on that. I would say we're fantastic on people right now, and that's been where we've put most of the effort in. Same thing for products. We have great products, but data collection's hard, especially across boundaries on different classification levels. These are some of the things that we own most of our processes. We own our capabilities. So if we're kind of just starting to get there, I think it's valuable for everybody who doesn't necessarily own any one of these pieces to go back and say, I wonder if we're at the level that we need to be in order to start putting these things out there as, no kidding, real capabilities, and not rush. And I think there's a rush right now to get after some of these problems, and I think that's important that we push the limits, but we got to do it such that we don't kind of burn the bridges that we have been building. So finally, one of the things I'd like to show is this. It's a kind of flow diagram, you could consider it, but this is the way that we kind of look at this, and we stole a little bit from some IBM research stuff. That IBM is not the best in the world at this right now, but we thought that this was a kind of an appropriate way to think about it. And it could be prettier and cleaned up, but I think it kind of encapsulates everything I've talked about here. Is when you look through at kind of starting at the top left all the way back around, these are the types of reinforcement processes, feedback processes that you really need once you have all of those kind of 5 pieces, is identifying those opportunities. So just like I talked about feature candidates, what's appropriate for automation? So that's project and product managers working with data scientists and ML researchers to say, hey, we think this is really a piece that we could take and apply some advanced methods to. Once you have those data sources, hopefully you already have those data sources, you can process those from data engineers and data scientists to build those right workflows. Exploring and visualizing, here's the data that we do have that could help us get after that problem, and think about, is it appropriate for any particular type of framework? Going through the process of making sure that when we're collecting data at the instrumentation level, right, is it clean? Do we need to do much transformation of that as we go through? Once we have kind of a solid data set that we know that we're going to be able to be repeatable on metadata or otherwise, then we can start actually training our models using data scientists and ML capable engineers to be able to build those. Start doing those experiments by deploying our best models and seeing if they work. Back to metrics and monitoring, right? Are they doing what we want to do? Are we getting good feedback from our users by measuring the types of success that we want from our user base, having the PMs, just like they would with any other feature or other product capability, make sure that we're on the right track through that customer and stakeholder feedback. And where there is benefit, we amplify it. Where we see that it's not working, we roll it back and we start the cycle over to make sure that we have those right capabilities. So really, running this process requires that whole cake, right? That whole puzzle piece set put together so that you can actually put this stuff into use day to day. If you try to do it too early, you're going to run into more roadblocks than you might like, or not be able to scale it quite to the level that you want to scale it. So with that, I appreciate your time. I'm looking forward to seeing what everybody else has to say during this day, and I wish you all the best of luck. I really want to see everybody do great work here around AI and ML for the Department of Defense, and everybody really understand their user sets and how they're going about it. Thank you.